I'm going to record. So all of you please listen. All of you please listen. Nadasha, listen. In the previous class, I explained this one, position time graph. This is very important. XT graph we studied. The time and position will be given. A moving body along a line. The time and position will be given. Based on that, we have to draw a graph. The time, position versus time. I don't want to explain again. We studied already. That is position time graph. I explain one question. The important point is, if the position time graph is a line, if the position time graph is a line, that corresponding to uniform motion or the moving with a fixed velocity. If the position time graph is a line, whether it is upward or downward line, it corresponding to motion with a fixed velocity. I explained one problem. So 2 problems I discussed, so I don't want to repeat it. So let me explain another question. This chapter is full of graphs. This chapter is full of graphs. The question will be like this. Maybe one graph will be given to you. Some graph will be given to you. You have to explain what kind of motion is this. Okay. So listen, all of you please listen. So XT graph is clear. So let me explain another one. Let me draw one graph. Can you see the screen? You can see the screen. Okay. Now this is time and this is position. Suppose a graph going like this. There is a question in textbook. Okay, it is actually given in textbook. It is there in textbook. Okay, a graph is going like this. What is this? It is the position time graph. It is the position time graph. As the time changes, 1 second, 2 second, 3 second, the position changes. The question will be like this. A graph will be given. Based on the graph, you have to explain, describe the motion. The question will be like this. Describe the motion. The 2 points you have to note, whether the body is moving towards right or moving backwards. Understood? I will definitely interact with you, but let me explain important point. A car or a body is moving along a straight road. We are learning the chapter motion along a line. Understood? Is the car origin starting from 0? Is the car moving towards right or moving backwards? That is my first question. Is the car moving forward or moving backward? Anybody? Fadil, you please tell me, is the forward or backward? Please respond. Forward. Nadasha, parayamo. Is the car, the position time graph of the car is like this. My question is the car moving forward or backward?
Forward.
Forward. Yes, it is very simple. You look at the diagram. As the time increases, 1 second, 2 second, 3 second, the position is also increasing. 1 meter, 2 meter, 3 meter. So as the time increases, the position increases. The graph is going upward. Means that as the time increases, the position is increasing. Position changes to 1, then 2, then 3, like that. As the time increases, the position +1, +2, +3, like that. So the first point is, describe the motion is the question. The first point is the object moving forward. The object is moving away or moving forward. Moving forward. This point you must include. Okay, moving forward. If you don't understand, you can ask me. The car is moving forward. Shivani understood. Rakshana, you are little bit late. All of you clear? Aryan, all of you understood? Please respond.
Yes, sir.
Okay, yes. Then second point. To explain the second point, I have to introduce a small mathematical concept. Actually it is in mathematics, okay, but I will discuss first, then I will discuss the second point. So the second point is what about the velocity, I mean what about the speed. Shivani, no problem, okay. The second point is about the speed or velocity. Is the velocity increasing or decreasing? That is the second point. If the velocity is increasing or decreasing. So I will explain, okay, whether the velocity increasing or decreasing, okay. So for that purpose I will tell you, look here, initially for a 1 second time, what is this is 1 second time, understood. Initially in 1 second time the displacement is too small, understood. Velocity is the displacement in 1 second, right? Velocity is what? The displacement in 1 second. So initially in 1 second time the displacement is too small. The displacement is too small. Then later in 1 second time, understood? Later in 1 second time the displacement is too large. I will explain in another way, don't worry, I will explain in another way. My point is this, initially in 1 second time the displacement is very small. This difference is the displacement, right? Later in 1 second time the displacement is much larger compared to initial displacement. So initially the velocity is too small. Velocity is the displacement in 1 second. So initially the velocity is small, but later the velocity is increased, understood? The velocity is increased. So in two ways I will discuss, don't worry. So in this way I can say that the velocity is increasing. As the time increases, the velocity increases. I will repeat, don't worry. The velocity increases or speed increases. So as the time increases, the speed of the car increases. In two ways I can discuss that. Speed, velocity means the displacement in 1 second time. Velocity is the displacement in 1 second time. So initially in 1 second time the displacement only this much small, but later in 1 second time too sharp, the graph too sharp means in 1 second time the displacement is much larger compared to initial. So initially velocity lower, but later velocity increased. So the velocity increases. The 2 points you have to add, okay. Describe the motion. The object is moving forward, and as it moving forward the velocity increases, or the body is said to be accelerating. The body is said to be accelerating. Velocity increasing means that we say the body is accelerating. I can explain in another way, but in two ways I can explain the change in velocity. This is the one way, okay. So all of you please write down. If you are 100% clear, you can raise your hand. If you are 100% clear, you can raise your hand. If you have any doubt, please ask. Rakshana understood. Fadil, Shivani understood. Raj Singh, you understood. Deva, if you don't understand, you must ask. Nadasha, Irene understood. Deva, everyone is okay, clear. So you understood. This type of question you can expect, okay. Then let me explain another question. I will discuss the textbook question, but before that let me explain some important graph related question. This is the time and this is the position, okay. There is a position time graph given to us like this. We have a position time graph given. The question is like this: describe the motion. All the questions, most of the questions are graph related. Okay, describe the motion. Okay, all of you clear? So question is clear. The 2 points you have to note. One is whether the body moving forward or backward. That is the first point. The first point is is the body moving forward or backward. The second point is it accelerating? I mean velocity increasing? That is the second point. Understood? So you know the basic things. A body moving along a straight road. Initially the time equal to 0. The body is here. As the time increases, the position changes. So is the body moving right or left? That is my first question. I will ask you question. Aryan ഒന്ന് പറഞ്ഞേ. 1 minute. Yes, I am recording the video. Aryan, please tell me, is the body moving forward or backward? Aryan, please tell me. Aryan. Forward. Are you sure? Then Raj, you please tell me, Raj, is the body moving forward or backward?
Sir, forward.
Forward, yes. Because I will tell you the reason. As the time increases, the position increases, right? The graph going upward, meaning that as the time increases, the position increases. Yes, moving upward. Graph is moving upward. As the time increases, the position 1, 2, 3, 4 like that, the position increases. So the describe the motion. The first point is the body is moving forward. That must be the first point, moving forward. Or moving away from us, we can say like that, moving away. If the body coming towards us, if the body is taking reverse, we say moving towards us. The body moving forward, the next is about velocity. I mean, is it accelerating or decelerating? I mean, velocity increasing means we say accelerating. Velocity decreasing means decelerating. Rakshana, you please tell me, is the velocity increasing or decreasing? Is the velocity?
The velocity is increasing.
Increasing. Are you sure? Then I will tell you. Listen. Initially, velocity is the displacement by time. In 1 second, how much displacement, right? In 1 second, how much displacement? In 1 second time, sorry. Yes, no problem. Initially, in 1 second time, the displacement is how much? Or okay, no problem. Initially, in 1 second time, this much displacement, right? Much larger. The graph sharp means you can think like that. The more sharpness, more upward means the more displacement. In 1 second time, this much displacement is there. Understood? But later, let me write some number, then you will not have any confusion. If I write some number, you will not have any confusion. Later in 1 second time, how much displacement? It is too small. Understood? Later in 1 second time, how much displacement? It is too small, like this much displacement. So initially in 1 second time, this much displacement. Large displacement means initially the velocity was too large, but later in 1 second time the displacement is too small. Understood? Too small. So the velocity decreased. Initially the velocity is much larger, but later the velocity is decreased. Understood? All of it clear? Velocity decreased. So velocity decreases with respect to time. Velocity decreases with respect to time. Initially high velocity, later the velocity is decreasing. So velocity decreases with respect to time. We say that it is decelerating. Decelerating means the car is applying a brake. Initially the car was moving so fast, but later the velocity decreases, means that the car has applied a brake, decelerating. Understood? These 2 points you have to note. So have you understood? This one is clear?
Yes, sir.
Okay, so all of you please write down. This is an example. Okay, this is just an example. All of you please write down.
Sir, can you explain what decelerating?
Decelerating means velocity decreasing. Understood? If the velocity is decreasing, we say that it is decelerating. That's all. Clear? Increasing velocity. Understood? Let me write using symbol. If there is increasing velocity, we say that the body is accelerating. I mean the acceleration is given. Understood? Accelerating. The velocity increasing, accelerating. If the velocity is decreasing, we say that the body is decelerating. Please memorize the term decelerating.
Okay, sir.
So please write down this example. If you are 100% clear and finished, then raise your hand. If you have written and 100% clear, then you can raise your hand. Devasri, Nadasha, Shivani, Fadil, Aryan, Rakshana, Raj Singh. Everyone is clear. Everyone is clear. Okay. Fadil, everyone is clear. Nadasha, okay. So the position time graph is clear. The question will be like this. Some graph will be given. You have to describe the motion. So position time graph is over, and okay. From position time graph, we are able to find the velocity. Okay, it will be asked as a question. Let me write it as a question. To find, just understand the method. There is no any numerical question. Just understand the method. There is no any numerical question. To find the velocity, let me say instantaneous velocity, or simply velocity. To find instantaneous. No numerical question will be asked, but the method you please understand. To find the instantaneous velocity from xt graph, from position time graph. Okay, from position time graph. All of you please listen. A mathematical concept is there. If you don't understand, I will explain. I will repeat. I am talking about xt graph, position time graph. Suppose an object is moving. Suppose let it be the position time graph. If the graph is a straight line, okay, we have a technique. If the graph is a straight line, we know how to find the velocity. I discussed in the previous class. But here the position diagraph is not a line. The velocities keep on changing. If the velocity time graph is a straight line, means it is a fixed velocity. But if the xt graph is not a straight line, it is not moving with a fixed velocity. So I want to find the instantaneous velocity from the graph. I want to find the instantaneous velocity. I will explain. There is a mathematical concept. I will discuss. Listen. For example, when time equal to say 3 seconds, just an example, okay? When time equal to 3 seconds, what is the velocity of the moving body? I want to find it. Or when time equal to 4 seconds, what is the velocity at that time? To find the velocity at a given time, the mathematical method is, I will tell you, the method is, yes, you have to draw a tangent. Tangent, the term tangent is familiar to you. You studied in 10th standard. The tangent means it is a line touching at that point. You just draw a tangent. Tangent means it is a line touching the point, touching the curve at that point. It is a tangent. This tangent will be making some angle with the horizontal axis. Understood? I will show you. This tangent will be making some angle with the horizontal direction. Let it be theta. Okay, let it be theta. Tangent, whatever may be the length, no problem. The tangent will be making some angle with the horizontal direction. Let it be theta. There is no numerical question, but as a theory question it will be asked. It will be asked as a theory question. So instantaneous velocity. Instantaneous velocity from xt graph is given by the angle we can measure. Understood? A tangent is drawn and an angle we can measure. Just take tan theta. Take tan. No numerical question. Proof is not required. Understand the method. Just take tan theta. I mean tan of that theta. You will get the velocity at that point. Velocity at that time. There is a name for this tan. It is said to be slope. It is said to be slope. Slope means okay. How to what extent the inclination is this? I will repeat, don't worry. So tan theta, there is a name for tan theta. It is said to be slope. Slope of tangent. Slope of tangent. So slope of tangent represents velocity. Slope of tangent represents velocity. So I will repeat. So if you are given a xt graph at a particular time, for example at 1 second or 3 seconds, at a particular time I want the instantaneous velocity. Instantaneous means the velocity at that moment. The velocity at that moment. What you have to do? Geometrically. Geometrically, how can we find the velocity at this time? You have to draw a tangent having any length. You have to draw a tangent line touching the curve at that point. Line touching. That tangent will be making some angle with the horizontal direction, right? Positive direction of x-axis. Let it be theta. Tan of theta represents, it is also called slope of tangent. That tan theta represents velocity at that point. So the method is clear. No numerical question, but the theory please understand. So have you understood how to find the instantaneous velocity from xt graph? All of it clear? All of it clear?
Yes, sir.
Fadil understood. Okay. So let me conclude. Let me explain a few important points. After that you can ask me doubts. After that you can ask me doubts. After that you can ask me doubts. Let me write it as a note. If you have a tangent like this, tangent means like this means the theta is an angle less than 90. Understood? If the tangent is moving upward tangent, can I say like that? If you have a tangent, upward tangent like this, then the slope is positive. Slope, I mean tan theta is positive. That is what I meant. Slope is positive. To explain the reason, I have to explain the trigonometry. Trigonometry you have not studied yet, so I don't want to explain the reason. You just understand this as a note. If you have a tangent like this, upward tangent, then remember its slope is positive. Understood? And the second case is if you have a tangent like this. If you have a tangent like this, for example, the tangent sometimes it may be downward. I mean slow tangent. Yes. For example, a curve is going like this. I mean a curve is going like this. If you draw a tangent at this point, if you draw a tangent like at this point, you will get a tangent look like this. Understood? You will get a tangent look like this. Downward tangent. We can, in simple language, we can say a downward tangent. Understood? In this case, the slope is negative. Slope is negative. So please note, if the if the road is upward, understood? If the road is going upward, then we say that the road has positive slope. Understood? If there is a road which is going down, we say that, I mean depression. If there is a road going like this, the road has a negative slope. So upward positive slope, downward negative slope. So it is required for comparing velocities. It is required. That's why slope is actually velocity, you know. So okay, one more point. After that you can ask me doubt. Okay, let me write it in sentence. The second point, third point is, the more vertical line, the more vertical tangent, the more magnitude of slope. Magnitude of slope. For example, we have a road like this. Understood? I have a road like this. We say that its slope is too large. Understood? We say that the road has much larger slope. But we have a road like this, a small, understood, angle. In that case, the slope of the road is smaller. Understood? So diagram is not required. You understand the sentence. The more vertical line means that the more magnitude of slope. The sign, we have a technique. For the sign, we have a technique. Upward, positive, downward, negative. Sign I have already discussed. I am talking about magnitude. Magnitude. So the more upward, the more slope. If the upward, I mean the smaller angle, we say that the smaller slope. Understood? I hope you have understood. It is required if there are certain indirect questions. So for comparing velocities, we sometimes require the concept slope. So all of you please write down all these things. If you are 100% clear and written, you can raise your hand. If you have any doubt, no need to raise your hand, but you have to ask me doubt. Okay? Devasri clear. Rakshana, Fadil, Raj, Nadasha, Irene clear. Shivani okay. So everyone clear? Everyone clear? So let me explain one question. There are questions in textbook. Okay. Let me give you another example. In some times the comparing velocity will be much difficult. The comparing velocity will be hard. In this case no problem, but sometimes it is very hard comparing velocity. Okay. Let me select one question from textbook, NCERT textbook. Okay. Just wait.